Well, section 4 of chapter 6 is kind of the middle of the chapter, so they put in this section in the book, which is a nice review of what we've covered so far in the chapter. So let's go through this first here. So we're talking about fractions, or rational expressions are fractions. So they're saying, hey, for the operation, if we have addition, they ask the question, do we need a common denominator? Well, to add fractions, we have to have the same denominator. So yes. And then they talk about procedurally, how do we procedurally get to this common denominator? Well, we write equivalent expressions with a common denominator, and then we add the numerators, keep the denominator. You could also put in there that you make sure that the fraction is in simplest form too. These tips and cautions here: do not simplify after writing each LCD. Instead, simplify after adding the numerators. And we talked about that a little bit with the addition and subtraction. Remember why we're creating a common denominator is that we want to make sure we have this same size item. If you're thinking about fractions like 1/2 and 1/3, it doesn't to add these two things to say how much pizza do I have. I have a half pizza and a third of a pizza. Well, I don't say I have 2 pieces of pizza. It has no meaning. And so I need to figure out what part of a whole pizza do I end up at the end of this. Well, the way you do that is to split the halves into sixths and put the thirds into 6, because 6 is a common denominator between 2 and 3. And then you end up with 3/6 plus 2/6, so you end up with 5/6 of a pizza. Okay, just to kind of go back to math. So the process of that, when I have 3/6, I wouldn't stop and say, oh hey, 3/6 isn't in simplest form, so, and go back to 1/2. I mean, you just be going back and forth. So that's a caution around that. Well, subtraction. Do we need a common denominator? Yes. So the procedural thing that they're kind of describing is the same thing. Our goal is, well, how do I get if I don't have a common denominator, how do I get it? You can use that. You can get there by prime factoring, basically, and then multiplying by your missing prime factors. You make fractions equal to 1 using those things, and then multiply. Because I can multiply by 1 in infinity of ways. I can make that x over x, or 2 over 2, or whatever missing prime factors I need to create my common denominator. And then the caution, which is a very good one, I see this error a lot, is that when we are subtracting something that's above a fraction bar, like a numerator, fraction bars really are grouping symbols, so we're really subtracting the whole group. So make sure that you subtract the whole group and distribute the negative, or the opposite of is another way to say opposite of this trinomial, if that's what it is. Make sure you do that whole thing. Then the operation of multiplication. Do we need a common denominator? No. So what do? We just multiply numerators and then multiply denominators. And the tip or caution, it says do not perform the polynomial multiplication. Instead, factor and try to simplify. So in other words, even if I have like 2/3 times 3/4, I will prime factor those and then list out all the prime factors as I'm multiplying, with the hopes to match up prime factors so I can simplify as I'm multiplying. In other words, if you multiply and then at the end, then you're going to have to factor to make sure it's in simplest form. Basically, the tip is don't do that. Leave them as factors, and then it will point to where you need to simplify. Division. Do you need a common denominator? No. Well, procedurally, what you do is you convert that division into a multiplication by taking the divisor and turning it into its reciprocal and change to multiplication. And the tip is always change division to multiplication first before you start trying to do your work, and then you basically do the same things you do in multiplication. And in the book, this is a nice deal here. I didn't leave a assignment in the math labs for this class to do a mid-chapter review, but there's a nice one in your book, and it shows a guided practice, and basically is trying to kind of walk you through the procedural things you'll do to do the first couple here, and then it gives you problems out of each section.